Nicole, let's check these out. We got 2 times the cubed root of 81 plus the cubed root of 24. So what we're going to do, we're doing higher order roots here. So what I'm going to do, I'm going to have to do a little factorization on this 81 and this 24 first. So 81 I know is 9 times 9, and that breaks down into 3 times 3, and so does this one, 3 times 3. Okay, so because I have an index of 3, I'm going to pick 3 of these 3's and I'm going to rewrite this. So let me just erase that and I'll show you what that looks like. So I'm going to have 2 times the cubed root of 3 cubed, so that's my 3 3's, times the cubed root of 3. That's just that additional 3. And the reason why I'm picking an exponent of 3 is because the index is 3, so all this will cancel eventually. Now with the cubed root of 24, we're going to do the same thing there. I'm going to do a prime factorization on 24. I'm going to go 6 times 4. 6 is 3 times 2, and 4 is 2 times 2. So again, there's my 3 2's. I'm going to pull those out. So this is going to be the cubed root of 2 cubed times my remaining 3, the cubed root of 3. So that's all we're doing. We're just looking for that number. You know, if we had a higher order index of that at a 4, I'd be looking for, groups of 4 numbers. But interestingly enough, check this out. I have an irrational number and an irrational number that have their like roots. So that tells me that I'm on the right track. So this is going to be 2. The cubed root of 3 cubed all cancels. I'm left with 3 there times the cubed root of 3. And over here, this is just going to be 2. Right, the cubed root of 2 cubed times the cubed root of 3. 2 times 3 is 6. Cubed root of 3 plus 2 times the cubed root of 3. And then we can just add our like roots. That gives us 8 cubed root of 3. There she goes. So I hope that one helped. Let me know if it doesn't. Now let's take a look at that next question you had. You had 8 1/5 times 5 1/2. So we had 8x to the power of 1/5 times 5x to the 1/2. Okay, so here we're just going to break this up. I'm going to do the whole number part first. So 8 times 5, that's going to give me 40. And now we're going to do our x's. And remember, when we're multiplying same bases, like here we have x and an x, we have to add the exponent. So the exponents is going to be 1/5 plus 1 over 2. But they're fractions, and we can't add fractions unless we make some equivalent fractions with the LCD. The LCD here is 10. 5 times 2 is 10, so 1 times 2 is 2. 2 times 5 is 10, so 1 times 5 is 5. Now we can add the numerators, so we're going to get 7 over 10. That's going to be our final answer there. Make sure always just to double check and make sure that your fraction is in lowest terms. So that's it, buddy. Hope that helps. Keep the questions rolling, and I'll talk to you later.